and welcome back to the course on art programming. In this section, we're talking about advanced visualization. Now, we've already touched on visualization here and there. We've talked about the matplot function when we were working with matrices, and we've talked about the qplot function. Now, in this section, we will be learning about the ggplot function. And the ggplot function is the main function in the ggplot2 package. It allows you for a lot of flexibility and a lot of control when you're working with your charts and graphs. As you'll see, we'll create some very interesting, very powerful visualizations, and you will learn a lot about this function. Now, a word of notice is that we opted out of working with the base package right away, or the base visualization functions, and that is because personally I find that the ggplot2 package provides so much more flexibility and so many more options when working with visualizations that you will never even want to go back to the base package. So I decided that there's not much point in wasting time on learning something that we're not going to be using in the long run. And also you should know that there are other packages in R that help you and allow you to visualize your data. But personally, I prefer ggplot2, so we'll stick to that one in this section of the course. And I look forward to seeing you on the first tutorial. Let's dive straight into it. Hello and welcome into the section on advanced visualization. I've got another very exciting dataset prepared for us today, and it's called the movie ratings dataset. We're going to be visualizing ratings of movies, Hollywood movies mostly, between 2007 and 2011, and we're going to create lots of different great and outstanding and fascinating charts and plots and graphs, and that way we'll learn a lot and have fun at the same time. Alright, let's check out this challenge. So, you have been approached as an analytics consultant by a movie reviews website. They are writing up an article analyzing movie ratings by critics and audience, as well as movie budgets for the years 2007-2011. This is the first time they are doing this analysis and they don't know exactly what they need. Don't you love those situations when somebody comes up to you and says, I have some data, analyze it, I don't know exactly what I need. Yeah, this is one of them. They have asked you to look into the data and provide them with 5 graphs that tell a story about the data. However, there is one chart the CEO specifically requested, a diagram showing how the correlation between audience and critic ratings has evolved throughout the years by genre. This is in addition to the other 5. See the next page for the CEO's vision. So it sounds like a pretty complicated chart, so the CEO decided to explain it with a picture. Here's his picture. Audience rating, critic rating, question mark. You know how CEOs are sometimes? Quickly scribble something on a paper, give it to you, and then you go and have to figure it out on your own. What exactly did they want? Where are the years here? Where are the genres? What is that question mark? Well, this is one of those very ambiguous type of projects, but it doesn't matter because we will still power through it and we will learn a lot along the way. Okay, so that was the challenge. Let's move on to where to get the data. So in order to get the data set, we need to go to superdatascience.com/our-course. And if you scroll down, here we've got section 6, advanced visualization. And so section 6, the challenge was that presentation with the awesome picture from the CEO. And we've got movie ratings here. So that's the CSV file that we'll need. And I actually wanted to show you inside the file. So this is what it looks like once you open it. And here we've got 1, 2, 3, 4, 5, 6 columns. If you scroll down, there's quite a lot of movies. I wonder how many of them you have seen. So just try see if there's a couple that you've seen. So I've seen Zombieland, for example. So 562 movies in here, and they have different genres: comedy, action, thriller, drama, horror even. So we've got quite a few different genres. And also we've got the ratings. So we've got the Rotten Tomatoes rating, and actually it might sound a bit confusing, but the higher the rating, it's actually good. It doesn't mean they get more Rotten Tomatoes. It means just that's the name of the rating, but the higher the better. And then, so that's the critics rating. So basically critics, they review the movie and they give their expert opinion on the movie. And so basically they rate it. And then once a sufficient number of people have actually seen it from the general public, they also rate that movie. And then, so you can kind of compare them. So here, the movie was rated 40 by the critics, but 71 out of 100 by the audience. So sometimes they match, sometimes they don't. And that's one of the things that we're going to explore. Another column, we have budget. So what was the budget of the movie? It'll be interesting to see, does budget actually affect the ratings and year of year release. So that's another variable that we'll be using, so comparing year by year. There we go. That's our 6 columns and that's our data set. Go ahead and download that and we will connect to it in the next tutorial. I look forward to seeing you then. Until next time, happy coding. Hello and welcome back to the course on R programming. I'm very glad that you got this far in the course, and as you can already probably tell from my voice, I'm super excited about today's tutorial. Today we're talking about the grammar of graphics, and in line with the topic, I've got a very vibrant and colorful presentation prepared for us. So let's dive straight into it because I can't wait to show you around. So what is the grammar of graphics and where did it all start? Well, as the story goes, it all started back in the 19th century. Here we've got a map which illustrates the French campaign or Napoleon's campaign against Russia back in 1812. And this map was created by a gentleman named Charles Minard, and he created it around 1869. And what it's showing is how the French troops started over here. Even by just looking at it, you can probably already guess what it's talking about. But just like going into a little bit of detail, like the French troops started over here on the border of Poland, and then they went, got all the way to Moscow, turned around, and went back. So after I told you that, now you can already, even just by looking at it, you can already gather so much information from here. You can see how many troops there were. So they started at 422,000 men. By the time they got to Moscow, it was 100,000 men, and when they got back, it was only 4,000 men. You can see how they split, how the army split at certain points in time. You can see the direction of travel. You can see which cities they went past, and you can even see the temperature. So on the way back, you've got the temperature here, and here it's in a bit of a different scale, but in terms of Celsius and Fahrenheit, it got so over here the coldest point was around minus 38 degrees Celsius and minus 35 degrees Fahrenheit. So it was very cold when they were returning, and yeah, so that wasn't in their favor at all. So we can see a lot of information from this one picture, and in fact Charles Minard was able to depict 6 different types of data in a 2-dimensional image. So here we can see the number of troops, the distance they traveled, the temperature, the latitude and longitude, the direction of travel, and also the time. So here you've got some dates over here, so you know when they were there. So that is an incredible amount of information, all in one 2-dimensional picture. And that's where it all started. That's where well, of course, you didn't call it the Grammar of Graphics. Grammar of Graphics came later. It's actually a book that was written in 1999, and if you find the original hardcover, it will have this image on top of it. But he started the whole concept of layering your image. So you can see here that there's lots of different layers and lots of different not just layers, but also different types of elements to your image. There's the data, there's some aesthetics, which we'll talk about, there's some geometries, there's some thematics, and so on. There's lots of elements to an image, and even though you don't think of it in that way, that's what constitutes the image. And that's exactly what we're going to be talking about. We're going to be talking about how to create charts that tell a story and what are the main components of them. So let's move on to the next slide. A chart, or a layer on a chart, will consist of the data, obviously, aesthetics, and aesthetics are things we see. So they can be like, you might have some information in your data, so it might be a number like revenue or an expense or some like number of people, but you can't see a number on a chart, right? You might see an x-axis, that's an aesthetic, or you might see a color is an aesthetic, or the size is an aesthetic, things you can actually see. Then there's geometries. So a size of what, or the color of what? Is it a circle, or is it a square, or is it a dot, or is it a line? So those are geometries. So that's only those 3 elements are absolutely necessary for you to create a chart. You have to have data, you have to have a way to translate the data into things you see, which are aesthetics, and you have to also explain how those aesthetics, which forms those aesthetics are going to take, what geometries. Okay, and on top of that, you can have additional layers. You can have another layer which is statistics. So you might make transformations to your data to create new variables and visualize them. Then on your chart, you might have facets, and we'll talk about facets in a bit more detail going further down in this tutorial, but basically facets are multiple of the same chart based on some category, or so like if you have many different years, then you might have the same chart for every year. Then you might have coordinates, right? So is your chart in normal coordinates, so like XY coordinates, or is your chart in polar coordinates, or do you want to zoom in, or do you want to zoom out of your chart, and things like that. So after everything's built, how do you want to actually see it? And finally, there's a theme. So theme is all the other stuff that goes on your chart. So it's things that make your chart pretty. And even like this might all seem very overwhelming at first, like 7 layers of information on a chart. You never thought of it this way. And personally, I was a bit confused at the first time when I saw this, but don't get scared, because right now we're going to go through all of these layers one by one on a real example, and it'll all make sense. So let's jump straight into it. Here we've got a chart which we'll actually create in this section of the course, which looks pretty cool, right? And it's showing some data on movie distribution, movie budget distribution. So you've got a y-axis at the bottom, which shows the budget in millions of dollars, and then the number of movies that were produced at that budget between the years 2007 and 2011. And then you've also got genres. So it looks like a pretty straightforward chart when you think about it that way. But now we're going to go through it layer by layer and see all of those things that we just talked about. Right? So let's get started. Here are our layers. So where's the data? Well, first of all, you can't see the data. You can see objects on the chart. You can't actually see the numbers. You can't see the data that was given to you. The data is somewhere else, somewhere in the background. So you've got the data, and the data that was used for this specific chart is the movie name, the budget, and the genre. And notice that we can't even see the movie name anywhere here. So this part of the data was not even used. We can see the budget and we can see the genre. So that's the data. Where are the aesthetics? Well, aesthetics, again, you can't see them. Aesthetics are things like the mapping of your data to the chart. That's like the intermediary step. And what aesthetics are we using? Well, we're using the x-axis over here, and the fill, so the color basically of these bars. And aesthetics basically means how is the data mapped? So how is this mapped to these values? So in our case, budget is the X value and genre is the fill, we can see over here. And then we get to geometry. So what I mean when I say we can't see the data and we can't see the aesthetics, because up to now, for all we know, these could be circles, or these could be triangles, or could be lines. We don't know what geometry these objects would take. So that's when the geometries layer comes in. And now, yes, we can actually see that they're bars or boxes. You can think of them as boxes. And that is all of the basic building blocks. Those 3 layers are absolutely necessary to create a chart. All right, statistics. So where can we see statistics here? That's our geometries. Now let's move on to statistics. Where can we see statistics here? Well, in this case, our geometries and statistics are actually combined, because we're creating a bar chart, which is not just a bar chart, it's a distribution, right? It's a histogram. And when we're creating this histogram, we're running a statistic. So we're grouping our data, which has like 500 rows, and we're grouping these 500 rows by some column, by genre. So we're saying how many movies fall into the genre of action, how many movies fall into the genre of comedy. So that is already a statistical transformation of our data, and we're creating a new variable, which is the count variable for every genre, which is basically not even present in our data. So we're creating a new variable and we're visualizing it. And that is what a statistical transformation is all about. It's about doing something to your existing data to create new variables that you're going to visualize. So in this case, our geometries and statistics work together to create this bar chart, which is also a histogram. Then facets, we're going to skip facets for now. We're going to move on straight to coordinates, because I'll show you facets after we get through all of these, just so that we don't overcomplicate the chart. So coordinates, what is that? Well, it's the coordinates that we have. We've got an x-axis and a y-axis. And also, you can see that this chart is actually zoomed in. So you can see that we can't see the top of this chart. So obviously it goes further there somewhere, maybe up to 100 or even further. But we have zoomed in. And so that is part of the coordinates layer. So not only we select that we want X, Y coordinates, we don't want polar coordinates, or we don't want a world map or something else. We want just X, Y coordinates, plus we want to zoom in into this part of the chart. So everything to do with how you observe your data, that is coordinates. And finally, the theme. What is the theme? Well, theme is everything else you see on the chart that's not related to the data. You've got the title over here, right? So we could have done without the title. Then we've got the color of the X and Y axis labels and the size of the text. You've got the size of the text of your tick marks, and you've got the legend. So not just the size of the legend, but also the positioning of the legend, the size of the text of the legend, the size of the title of the legend, and all those things. So all of these things that make the chart look pretty. And in fact, they have a name. They're called non-data ink. So they're completely not related to the data, but they're still present in the form of ink on your chart. All right, so those are the 6 elements and facets. Let's just quickly look at facets. Facets basically means if you had, instead of this one chart, if you had a chart like that for every year. So on the right here, you can see that there's multiple years, and basically that's what facets means. That's faceting your chart. And that's how all these 7 layers work. It doesn't necessarily have to be in exactly that order. So from some books or from some other sources, you might find that these layers are put into different orders. Personally, this is my interpretation of everything. This is how I best understand it. So feel free to look around, and maybe your own understanding of ggplot2 and a grammar of graphics will be a bit different. But in essence, those are the 7 layers that you require, or that are required to create a beautiful, stunning visualization. And we're going to go through them one by one in this section of the course, and I can't wait to jump into it. I hope you enjoyed this presentation, and I look forward to seeing you next time. Until then, happy coding. Hello and welcome back to the course on R programming. And today we're talking about factors. So first things first, I've got an image in front of us, and this image will be like our map. It'll be guiding us through the section so we know what layer of the visualization process we're talking about in the current tutorial. And as you can see here, today we're talking about the data layer. So the very first layer, we're going to be fiddling around with our data set. So let's dive straight into it. I've got RStudio opened up here, and let's load the data set. So first of all, get working directory. Mine is correct, but for practice sake, let's say set working directory, and let's set it to what we want. Check it again. And remember, on Windows, it's a bit different. All right, now we're going to read the data set, and it's going to be read.csv. And here we're going to say movie ratings.csv. If I run that and I look at the top rows, we'll see that we've got the top rows here. Let's make some space. All right. Great, the 6 columns are here. Where are these dots coming from? Well, if we look at the original file, you'll see that there are spaces, percentage signs, dollar signs, brackets, and all those symbols cannot be included in names, so RStudio replaces them with dots. Okay, so we want to fix that up. Obviously, it's not convenient to work with names of columns like that. So let's go ahead and use call names, our favorite function, and run that. So you've got the column names here, and as we know, we can actually assign a value or a vector to call names. So let's type up a vector. We're going to say film. We'll keep the first 2 the same, film and genre, and then we're going to say critic rating. The next one will be audience rating. All right, and then we've got budget, and let's remember that budget is in millions, so let's put that in here as well. And finally, we've got year. If I run that now and I look at the top rows, you see that now everything's beautiful. Let's just check the bottom rows as we normally do, just to make sure that everything's consistent, everything looks good, it hasn't been shifted or anything. Great, now let's look at the structure. And what do we see here? Well, this is the point where we start talking about factors. You can see that we've got 2 columns that are actually recognized as factors. And what does that mean? Well, a factor in R, it's a very simple concept. It's basically a categorical variable. It's a way R works with categorical variables. And as you can see here, there are numbers. So there are levels here and there are numbers. So what happens is R looks through your column, finds all of the different words that there exist there: action, adventure, romance, comedy, thriller, horror, and so on, and assigns each word a number. So if we look at the top, you'll see here comedy, adventure, action, adventure. And R has assigned the numbers 3, 2, 1, 2. So comedy, adventure, action, adventure. We don't really mind in which way R assigns these numbers, because we were never going to be using these variables or this column for numerical operations anyway. It's just, for us, it's easier to understand words. For computers, it's easier to understand numbers, and that's how R just stores these factors for us. And the giveaway here is that it's a factor, and also the word levels, it always gives away a factor. It tells you what levels exist in that factor. All right, so that's our intro to factors. Pretty simple concept. Let's look at summary for movies now. Let's see what we have there. So we've got film, that's the name of the film. It's also recognized as a factor, as you can see here, but we're not going to be using the name of the film at all, because we're actually interested in the trends and averages and, you know, all these aggregations of our data rather than individual films. Genre, yes, we're interested in genre as a category, and that's good that it's recognized as a factor. Then we've got critic rating, so you can see that the minimum is 0, 97 maximum, average 47. Average for audience rating is a bit higher, so audience seems to be a bit more forgiving to movies. Then budget, so you can see that there was actually a movie that had a budget of $300 million, which is an insane amount. And finally, we get to year. What we see here is that R is treating year just like it is treating these three columns. So it's saying, oh, the minimum has got an average, it's got a maximum. But do we really want that? Like, let's ask that question. Do we really want year to be a numeric variable? Are we going to be adding them? Are we going to be averaging them out? Are we going to be doing any arithmetic operations with year? Well, the answer to that is no. We want year to be a categorical variable. We want year to be just like genre. So we can group by year, so we can color things by year, so we can compare year to another year, and so on. So we want year to be a factor. That's what we're saying. And right now we're going to learn how to do that, how to convert a non-factor numeric variable into a factor numeric variable. Because the thing is that R, when it sees words, it chooses to recognize them as factors because there's not many other options. And when it sees numbers, by default, it thinks that you're going to be using them as numbers, but years we're not going to be using as numbers. So let's see how we can convert years into factor. So the function that we need is actually called factor. It's a pretty straightforward name, and all you have to do is put your vector inside the function. And if we run that, oh, of course, I need to tell it which data set we're using, movies year. So if we run that, you'll see that that is our variable, like our vector, and now it has been converted into a factor, and the giveaway is here is that it has levels. So it's got all of these levels, and that's exactly what we want. So the last step would be to take this actual column in the data set, so this is the column in this data set, and assign it the new vector, which is produced from that same column by factorizing it. So it's a bit of a tricky operation, but actually it's pretty straightforward. We're just taking the column. Well, here we're converting the column into a factor. So here we've got a vector, which is a factor here, and we're then assigning this into that same column, which it used to be. So if we run that, now if I look at summary movies, you'll see that movies is no longer a numeric variable, it's a factor, and we can actually prove that if we go into str for structure, movies, run that. You can see that it's a factor with 5 levels, so there's 5 different years in the data set. There we go. That's how we work with factors. Very, very simple things, but it's always important to, at the very start, set exactly what you want from your data. Do you want a variable to be a factor, or do you want it to be a numeric variable, or do you want it to be completely something different? So those are the important things, because then going forward through this section, we're going to be relying on that quite heavily. And I look forward to seeing you in the next tutorial. Until then, happy coding.